So yes, you guys have no idea how dumb this whole thing is. Um, this is part of a project I'm doing. I'm rebuilding a 1978 GMC motorhome and refitting it with all kinds of crazy stuff. But it's a pretty complicated motorhome, and there's a fair amount of wiring in it, and a pretty complicated dashboard. And I wanted to eliminate a bunch of the wiring by doing wireless control, but also at the same time have local control, because having to take your phone out to turn the light on and off is kind of ridiculous, or having to do it from the dashboard. So everything has a little fallback. But anyway, so so this is a little device called the ESP32. It's a microcontroller with Wi-Fi and Bluetooth built in and a few other little features. This is what a MOSFET board looks like. It's just some of these, MOSFETs are a relatively high current DC semiconductor gate. I've got it connected to a bunch of LEDs that just are serving as an example of a taillight. This one here is breadboarded as a sample of one of the lights in the motorhome, and all of the lights will be all the interior lights will be wirelessly controlled, but also local push button controlled. And then there's a level control system that has a compressor and a couple of solenoids that manage the airbags. The original thing, of course, was analog. It was built in '73, and it's a marvel. But switching it over to fundamental electronics makes a lot of sense. So anyway, the dashboard this will be part of the dashboard. This is a little touch panel. And on the back is a Raspberry Pi little Unix computer, and this touch panel. I mean, all this stuff is remarkably inexpensive. This whole touch panel has cost me somewhere around $80. This is the server for the system. Another little touch panel running Raspbian Unix, and that's a Raspberry Pi on the back. So the way this works is any computer can talk to I won't go into the details of what MQQT is, but it's a control protocol. Anything that's connected to the local network can send a request to the server. The server acts as a broker, figures out where the command should go to, and sends it on. And then there's some error handling. As I said, I wasn't going to go into it. But here's how it works. So if you step on the brake, this brake light will come on. You turn on the taillights, tail light comes on. Do a turn signal, gives you a sequential turn signal, and likewise for the other direction. And because this is wireless, and because this is all operating through this broker, anything that's connected to it, like this iPad, I turn the brake lights on, and you can see I'll turn that on and off, and you can see on the computer the brake light switch is moving, and of course the light comes on. And I can hit the turn signal. It's a modified version of the turn signal. That inside of a red housing, you can still see the brakes are on, but you have the sequential turn signal. So so the whole idea is it could be a replacement for the existing turn signals and taillights and so on. But in reality, I'm not going to mess with that. In reality, what I'm going to do is use this. This is a big LED strip lamp that combines tail light brake light, backup light, all in one unit. That'll go across the back, and I'll also put one on my tow vehicle just for better visibility. I mean, the GMC, the lights on this motorhome, the taillights are pretty small and not all that bright. Compared to anything modern, it's pretty wimpy. So that's the plan. But anyway, this stuff is mostly just an effort to keep my brain alive. Learning digital electronics at 73 is kind of an interesting challenge.